Convert the following radicals to mixed radicals in simplest form. As you can see, some of these, like A and B, are already mixed radicals. But we're still going to follow the same steps of pulling the highest perfect square out from underneath the radical sign. In A, that would look like 2 times the square root of 64 times 3. The 2 is always going to remain as the coefficient. When I pull out the square root of 64, I'm just going to multiply it by whatever was already there. In this case, that's the 2. So 2 times 8, root 3. And then just simplify. 2 times 8 is 16, root 3. Again, you can always check that these two things are equal by entering 16 root 3 into your calculator, comparing the answer with 2 root 192. In part B, some people will shy away because the coefficient that's there is a fraction. But remember that whether it's a fraction or not isn't going to change the steps that we follow. So 3/4 is on the outside. Underneath, I'm going to change 160 to be 16 times 10. So 3/4 will always be outside. And then I'll pull out the square root of 16, which is 4. So 3/4 times 4 becomes my coefficient, and 10 is underneath. Now you can simplify 3/4 times 4 on your calculator, or if you remember your fractions, the 4's just cancel out, leaving me 3 root 10. In the last case, root 7 over 9 can be rewritten as the square root of 7 divided by the square root of 9. The reason I did that is because I can actually take the square root of 9. I know that answer is 3, so root 7 over 3. You're actually done. This is a mixed radical, but it's not as obvious to some people. In the cases where the radicals are in your numerator, you can pull the coefficient, if there is one, and the denominator out. In this case, if you don't see a coefficient, you can assume it's 1. So root 7 over 3 is the same as 1/3 times root 7.